Well, g'day, Max here again. Welcome back to the shop. Well, welcome to 2022. Another year ahead of us. So, anyway, it's the 2nd of January today. So I thought, what a good time to crack back on with our LA Rocheleau grinding fixture. So we made good progress on the new shop over the Christmas break and leading up to the Christmas break. So I'm just having a bit of a break from that, as in a couple of days I'll be back to my normal daytime job and things will resume back to its normal pace. So the lathe, as we've seen, we've gone as far as we can with that till the bearing shops open up. So there are a lot of new jobs I want to start, and I'm not refuse to start anything nowadays until I finish what I'm working on. And this has been dragging on for a long time, and what the big interruption this year will of course be the shed progress. So that's priority. So anyway, let's swing you down and we'll try and remember where we're at with this little jigger here. Okay, if you remember quite a few videos ago, we'd made up this sliding mechanism here, and the last part we made was the square support bar for the finger rest that comes up to support the cutter when you're sharpening these sides along a cutter. So what we have to make now is the clamping arrangement for the adjustable finger rest, which is this part here. So it's a clamping arrangement, so you can clamp it anywhere along the length of the square bar. Plus it also has an adjustable height screw mechanism here to adjust the centre height of the rest, the tooth rest. This is the design that I've come up with. It's pretty, well, it's similar to the LA Rocheleau one. So the square bar comes through here, and this is a clamp, pulls down with two 1/4 inch cap screws onto this block, and there's a hole through this block which will take your threaded adjuster rod for the finger pointer. So this part here is going to be this part here. So we have a piece of 7000 series aluminium billet here, so we'll get it out of that. Okay, quick deburr. Flip her over and do the other side. Beautiful stuff to machine, the 7000 series stuff. Right, next setup, just a couple of parallels. Drop our block down. We just want to take a nice cleaning cut across the top of the block there. Parallels are tight, good to go. Okay, I took a second light finishing cut then, as I felt the steps between the different cuts were a little bit out there, but it's settled down beautiful now. Just you get, because of the load on the tooling will cause, on a roughing cut, will cause you to get a step there as well. So that's come out well. There's nothing I can detect even with a fingernail. So beautiful. Okay, we'll get set up now for our V-groove. So our setup for our V-groove, it's a half-inch. It's a V-groove to go around a half-inch square. So gripping by the two sides that we had just previously machined, we'll lay the block now. When you're gripping like this, you need to really give the part a good wiggle as well, just to make sure you are gripping it square to the vise. Just rock it round and let itself square up. So we'll just use the butt or the square. It's a good brown and sharp one, this one, so I know it'll be well enough accurate for what we are doing today. So I'm just going to push down and lay the block on top of the square, like that, and nip our vise. Everything feels solid. I can't feel any rocking and rolling going on there, so we're good to go. So we'll get a cutter set up and we'll cut our groove. If we look at our part, the same plane as it's sitting in the vise, so we come down with our cutter, we touch off on this point here. Now the distance from the edge of the part to where we touch off, at this stage I'm leaving it a bit on the wide side. I've just got a measurement straight off the drawing here, and I've just allowed an extra couple of mil, as this side still has to be cleaned up. When we do that, we can bring it to the appropriate dimension here. So we come down, we touch off here. As this is a 12mm square, when it's clamped on the bar, we're going to come down 12.5mm. So when it's clamped, there will still be slight clearance on either side here for it to give room to clamp up on. Okay, so just a bit of Sharpie so we can see what's going on. So we've just scratched our Sharpie line there, so we'll zero the knee. We've got to come up, what was it, 12, where are we going, 12.5, I'm going to write that down. So that'll give us 0.2 mil aside, so 0.4 mil gap once both halves are flipped over back to back in their clamping position. So I'll come up 2 turns on the crank handle, which will be 5mm. We'll just do 5mm cuts and slowly work our way through it. Okay, that's our slot. That's our guide. That sits in there nicely. Okay. We've got our part inverted now in the vise over the other way, so we're just going to take a really light cleaning cut over the surface here. Okay, that's all it needs. We don't have to go the whole width because we're only using part of the block of steel. So I'll get this deburred and we'll get our excess chopped off. Okay, we're just chopping our part to length. It's a bit of a sketchy setup. It's doing the job okay. We do have to modify the saw for cutting short length pieces. Well, I don't know why I bother with a milling machine. After that sketchy setup in the saw, this thing has never ever cut so square before in its life. Absolutely spot on. Nice finish too. Alright, let's get on with trimming up our sides, so we'll bring them down to dimension. Now our next stage is to mill this to width. Now on my original drawing here we have a width of 44 millimeters. Now off camera I did play around with that and I've amended that dimension, our total width, down to 40 millimeters. So I just had a play on one side and we're still a bit oversized here, but I want to make this part as compact as possible. So we have here our saw cut edge, which we haven't machined yet. So let's go through the process, how we set this up and get our dimension working off our V-groove. Now it doesn't matter which surface we start with, whether it's our saw cut edge or our machined edge, makes no difference whatsoever, as the bottom of the part does not come into contact with the base of the vise at all. So we slip our part in, we slip a parallel up to the part. I'm just going to nip get the jaws a bit closer, and then what we use is two. You can use, well, I'm using 2 end mills. You can use 2 dowels or whatever you want to use, something of the appropriate size. Now if we lift our part up, we can slip one under each end, making sure our parallel is pushed up against the part to ensure the parallel is under the centre of your dowel or end mill or whatever you're using, doesn't matter. Let's give it a light tap down, make sure our parallel's tight, give it a nip. Okay, that's tight, our parallel's tight, so we're located securely on our end mills or dowel pins or whatever you use. So that's probably a better shot there. As you can see, the parallel, although being hard up against the part, just to keep it all square and in line, the axis or the centre of the parallel is under the centre of our milling cutter or dowel or whatever you're going to use. Now it looks like it's on the flutes here, which it is, but further on in it's under the solid section of the end mill. So when I mentioned appropriate size dowel before, referring to this round thing here, appropriate size is you want to be at least 2/3, or the tangent point wants to be at least 2/3 to 3/4 of the distance out of the flat, so you need to be in this area here. You don't want to be right on the corner, as well as you don't want to be right a small diameter right down the base of the groove. If you have too small, you cannot get into measure. Too big, you may be contacting right on this point, which is not good. You need to be 2/3 to 3/4 of the way down is fine, and that gives you then room to, you can measure down on top of your dowel and not interfere with this face here. So to get your reading, which is this dimension here. So in order to determine our dimension from the top of the end mill to the top of our part, to make sure we hit our final thickness, it's half the thickness of the part, which is 20 millimeters, minus 1 radius, which is 7.935 millimeters. 20 minus 7.935 is 12.065 millimeters, or 475 thou, which we pick up off here. We can measure that. It can be measured with a vernier, or it can be measured with a depth mic, or several other options there, but vernier or depth mic is the easiest to me because that's what I've got. So we just blued up the corner of our part with a Sharpie marker, and I have this adjustable parallel set to 13 millimeters, so we're a bit oversized of our finished size of 12 millimeters or 12.065 millimeters. We'll just put a scribe line down there. So we can mill away. Once we come close or near to that scribe line, then we can break out the more serious measuring gear and get a depth down to the top of our dowel there. Okay, let's get a measurement now. We've come down, we split our scribe line, so we'll get the measuring gear out. Okay, quick check with the verniers. I hate measuring things like this on the ends. You always get discrepancies. Okay, 13.02, 13.02, 13.02. Okay, so we managed to split our scribed line fine. So now we'll double check our readings with the depth mic. Okay. We're a bit over 512. Let's say 512. So we're within half a thou of our depth mic reading. Sorry, our vernier reading. So we'll go with the depth mic reading. So what do I say? 512. So our cut come off. What do we got? Our finished is 475, which is there. Okay, so we got 25, 30, 37. Yeah, we'll take 37 thou off on our final cut, and we'll be down to our finished dimension. The other thing too, when we go to do finish size the other side of the part, all we have to do is leave our knee where it is, not change any of our height settings. All we need to do is flip the part over 180, as we're still referencing off the V-groove, and we can just take a cut straight across the other side. There's no measurements or anything like that involved. Right, we'll bring the table up 37 thou for our final cut, which is 0.939 millimeters. So we'll just round that off to 0.94 millimeters, which is just there. So I'll take our final cut. Quick deburr. Okay, let's have a final check of our dimension. So final dimension is 0.475 thou. Right on it there. And we're right on it there. So we'll go ahead now, we'll flip the part over and take our finished cut on the other side. Okay. Okay, same deal, quick deburr and a measure, and if everything's gone well, we should be 475 as well on this side. which we are. We're right on it there. And we're within a couple of tenths of it there. So, no, happy with that. See, that's pretty well right on it. Yeah, no, we're smack on it. So we're good to go. So we'll take it out of the vise. One thing you do have to check when you use this method with the end mills, I'll come around the other side, is I do mic the shanks of the end mills up just to make sure they are exactly the same. As if they're different, well, if there's differences, yeah, you will get a bit of a weird way that the part clamps up. Okay. So next operations on this part, we've got some holes to do and a few other features to machine on it, but we're going to have to leave that for now as we have a more important job to do. Yes, so that's as far as we can go on our block for now, as we have the bearings have come in for the lathe, so I need to swing back over onto the lathe and get this headstock back together. So anyway, thanks for watching, and yeah, tune in probably another next week. We'll have the videos putting the lathe headstock back together. So anyway, have a good new year and see you next video, hopefully. Cheers.